I'm Dave. This is another installment of Invitations to Math coming to you from Hypatia Math Ed. Today we're going to talk about irrationality. In particular, the square root of 2. If you are a student in school or have been a student in school at some point, about maybe 7th grade or on, you encountered the idea, somebody at least told you that the square root of 2 is irrational, and that was the end of the story. What does that even mean? They just told you to remember that fact and then be sure to remember that on the test because the test scores are so important. You know, they follow you everywhere like an albatross around your neck. So what is the deal? Why do they just tell you this fact and don't explain it at all? Okay. Well, I don't really know, but you, if you're any kind of learning person, curious person, you want to know. Maybe you didn't ask in class because that's just not what happens in class. You don't ask questions. You know, the culture is not such that you're comfortable asking questions. That's the experience of most of you. So here I am to tell you some more about this situation. Why is the square root of 2 irrational? What does that even mean? So you're familiar with that symbol, hopefully. If you're not, you might want to go and find out more information about square roots. But I'm assuming that you have encountered square roots and done some square root calculations. For example, you know that the square root of 4 equals 2, and the square root of 1 equals 1. But the square root of 2 causes problems, and then they just kind of wave their hand at it. Oh, it's irrational. What does that mean? Well, it means you can't find rational. Oh, so we're just going to circularly define itself. What's irrational, not rational? What's rational? Well, what's rational is fractions. So they tell you it's irrational, but they don't prove it. They don't even give you any plausible explanation. Maybe if you had a good teacher, they would kind of lead you through a calculation that turned into some kind of problem, at least a problem in terms of not being able to find an exact value for it after a certain number of steps. So square root of 2 is irrational. What does that even mean? Well, it means it's not rational, so we need to know what rational is. So we say that a number is rational I'll give you kind of a non-technical definition of this. A number is rational if and only if we can find two, let's say whole numbers. Let's use whole numbers. Two whole numbers, A and B, such that a number, I guess I need to name that number, so a number n is rational if and only if we can find two whole numbers, A and B, such that A over B as a fraction, A over B equals n. Okay? Now, some of you might be thinking, oh, wait a minute, don't you have to say B is not equal to 0 because you can't divide by 0? And why is that, by the way? Well, we can talk about that in another segment, but the way I pose the definition is that you're just trying to find two whole numbers that are equal as a fraction to this value n, or to this number represented by n. So we would naturally avoid having 0 down here. We're not going to go looking for, if this is a non-zero number, we're not going to go looking for anything that involves 0. If it is 0, then we know we can't have 0 down here, so why bother saying it? But technically speaking, b should not be 0, and we'll talk about that in another segment. So, okay, now, so square root of 2, basically what we're saying, if the square root of 2 is irrational, as has been claimed, but not explained, if it's irrational, then they're telling us that we cannot find, no matter how long we search, we cannot find any such a and b. We cannot find a fraction that would be equal to the square root of 2. How on earth can you prove such a statement? How can you spend your time not finding things? Well, you look for it and you keep missing it, no matter what you do. So that's how it started out in history. When they first encountered this idea in history, going all the way back to Pythagoras, when they first encountered this idea, they did a lot of searching for a rational value for it. At least that's what I would guess. And it wasn't until thousands of years later that we came up with a proof that relied on deduction, logical deductions from a certain set of assumptions. But before that, it was just a lot of searching and searching in vain, and then they just kind of said, well, I guess then it must not be. And then they started looking at how to justify that assertion in a non-empirical way, in a deductive way, right? But it started out empirically. As most mathematics does, it starts out empirically. So what is the empirical justification of this? Well, we try to come up with a guess. Square root of 2 equals a over b. We try to guess two numbers, a and b, such that this would be true. So I'll give you a moment to think of a guess, play around with it, see what happens before I continue with this conversation. And I would urge you that you should take a moment to try to construct such values, a and b, and then see what happens when you do that. Then you'll better understand what I'm about to say. Okay? So pause and take a moment to figure that out, and I will see you in a minute. All right. Hopefully you have done some calculations and figured out that, wow, this is really troubling, no matter what I do. So let's think of this. Let's try 1.5. So 3 halves. And I'll put a question mark up here. We don't really know yet. Okay? Is the square root of 2 equal to 3 halves? Well, the only way to know is to square 3 halves and see if we get 2. So if we square 3 halves, we get 9/4. And 9/4 is not 2. In fact, it is bigger than 2. It's 2 1/4. So I guess I should make that clear. It's 2 1/4. So not exactly 2, so it's bigger than 2. Okay. So then that didn't work, so we come up with another guess. Now, the way that this was done originally, going all the way back to the Babylonians, was they would come up with a guess, and then they would find the error, and then they would take the average, and they would just repeat this process with every new average. So what do? We take 3 halves. So if 3 halves squared is not equal to 2, it's not the square root. So now we've established that this is not the case. What's the error? So the idea was to take 3 halves times x and say it's equal to 2, and then solve for 2, or rather solve for x. Now the Babylonians didn't do it in our modern notation. They had algorithms that amounted to the same thing. But we're not going to worry about their particular way of doing it. because this pretty much establishes the same idea. So what would x be? Okay, so how do we solve this equation? If you're prepared for this topic that I'm discussing, then you'll know that we multiply by the reciprocal on both sides. So we multiply both sides by 2/3. So multiplying both sides by 2/3 gives us x equals 4/3. Okay? So x equals 4/3. Now, if you square 4/3, you'll see that it's not equal to 2. It's actually less than 2. It's 1 1/3. And so I say that's less than 2. Or rather, I should say it's less than the square root of 2. Okay. So we now have something, we have sandwiched the square root of 2 between 3/2 and 4/3. So now we have some bounds on the square root of 2. So what did the Babylonians do? And this is still what we would do today, in a sense, to understand any rational approximation to the square root of 2, although there are other techniques which we'll discuss in another segment. So we take these two values and we average them, because the answer must be somewhere in there, in between these two. So the average would be in between these two, so let's see what happens. If we average these two numbers, I guess I should just come down here. So if we average these two numbers, 4/3 plus 3/2, so the average of those, so we do that to find the average, that would be, let's see how good your mental math is. So let's see, that's going to be 8/6 plus 9/6, 17/12 would be the average. So is that the square root of 2? That's our next guess. So again, we square that. And so 17/12 squared equals, well, that would be 189 144ths. And if you try to come up with 2 there, you're going to run into a problem. So that's not equal to 2. It's equal to 1 and, let's see, what would that be? 1 and 55? No, 45. 1 and 45, 1/44. I believe that's correct. Let's see, 45, yep, 89. Okay, so it's less than 2. Okay, so again, we got something less than 2, and we must then find the error. So this is an approximation of the square root of 2, 17/12. But what's the error? So we take 17/12 times x, solve for n equal to 2, solve for x, and we get some other value, which we then take the average of. But if you do this enough times, you will see that it's a never-ending process, it seems. You never seem to get exactly 2. You start improving these bounds, essentially. Okay, so the 17/12 is a better approximation. So we would put 17/12 in between 4/3 and square root of 2. And then the error would be a better approximation on the other side. So we just improve the bounds. And that's the best that happens. Now, hopefully you prove me wrong. You find a rational equivalent to the square root of 2 by repeating this process. You make a guess, you find that it's not equal to the square root of 2, you find the error, what times that would make 2, and then average those two values, and then you have a new guess and repeat the process. And I'm saying that will just keep on happening to you. You will never get exactly 2, but as I like to say to my students, prove me wrong. That's when the mathematics happens. That's when you learn something, when you attempt to prove me wrong. So I will leave this problem with you. Try to improve these boundaries. find new values that fit better into this boundary, that push these old bounds outward, and further hone in on the square root of 2. All right, so I'll leave that problem with you, and thank you for watching, and I will talk with you soon.